Hello everyone, today I am welcoming you in ARC315 Digital Visualization Lecture 5 and the lecture for Rhino 2. So today we are going to talk about surface editing, solid tools in Rhino, and how can we basically convert a 3D surface into 2D presentable line drawings and model drawings. So let's get into it. As always, whatever command I give will be written into the top right corner of the As always, whatever command I give will be written into the top right corner of the screen. Like if I press L, it would be written over there, and basically everything would be the same as our previous class. So let's get into it. Now, what do I mean with surface edit? In order to surface edit, let's make a surface first. Let's use the loft command from our previous class to have a better understanding of what is it going to be. So let's make 3 ellipses in any type of random order and make a loft out of them. Make the viewport shaded, and this happened. So this is okay for now. Now let's say I want to trim this basic cylindrical lofty surface into a diagonal manner. How do we do it? One thing that is to be kept in mind, and we have to keep our mind creative about, is that any command we have already used in AutoCAD could be used in 3D mode in Rhino. Say, let's say I want to trim it. All I have to do is make a line in 2D elevation, select it, and then trim with its reference. Same goes for extend. And for extend, things get a little bit, what we can say is limiting, but still we can extend. For example, let's say we have this type of cylinder. Let's just extrude it, open cylinder, and we have some sort of pipe. And for pipe, the command would be just pipe. This is a pipe. Let's see what happened in 3D. Something like this. Let's keep it into somewhere around here. And now, if we try to extend, we can select the extrusion, then we can basically just I have extended the line. I could extend the surface. Let's try it one more time. And let's see. You can see here that the line has been somewhat extended, but this is not what I wanted. So yes, we could do that. We can extend a basic line from one point to another. Also, another way of doing it would have been, I could basically just scale it like this. Scaling is really simple with Gumball. I just have to align the Gumball with the object and then trim it along the line. So we could do that as well. So yes, that is one way of doing it. So we can basically trim or extend. Now what about fillet? Just makes a box. Let's just make a box. And we can see the edges are quite sharpened. So we can type in fillet, and when we type fillet, we can see that there are different options of fillet, like fillet corner, fillet edge, fillet surface. So for this is a box. We are not going to fillet the surface of it, we are going to fillet the edges. So let's select the fillet edge and select one specific fillet and change the radius into 2. It's the next radius, so yes, it's done. And you can see that there are lines, so it may give you the illusion that this is not smooth, but if we turn it into rendered mode, we can see it's perfectly smooth. So we could do this for all the surfaces. Just type in fillet edge, next radius into something more than 2, select everyone, and it's done. A perfectly chamfer box. So we could do that as well. Now there are some things that are not into AutoCAD, but we could do here anyway for surface editing. Like what? Let's say we have a fillet, we have a very lofty shade somewhere, something like this would be the profile, and as you guessed it, I've lofted it, so let's do that. Let's make a loft out of it. Sorry, yeah. So this is a loft. Now let's say I want to put some type of structures or structural line in it. So let's say I want to put some sort of hexagonal structure. All I have to do is create the drawing. There are multiple ways of doing it. So let's go with the project first. There is a command named project. So what would that do is, let me just show you. It's quite fun, as all the commands in Rhino are. I'm just copying, nothing fancy. Let's say I have copied some type of hexagonal forms and I want to project them in this curved surface. For that I would need to put it somewhere upper level. Just delete the edge of this curved surface, go to the top view, type in project, and then select the surface. You can see this happened. This is quite fun to do. If we have something in our planar view and want to project in our curved surfaces, we can do this and it looks like this. Another interesting option would be to blend different surfaces. So let's say we have some surfaces like this. Let's copy it into different direction. Just turn off the ortho. Change the direction a little. And so far and so on. We have blended it and we have to blend them. Now let's say blend surface, or we could also blend edge, but let's say we want to blend these surfaces. So just select the edge of the surface and we can see this happens. So this has twisted. Let's say I want to do it again, like this, and yes, that's the way it should be done. So we can change the curvature of it, we can change different curvature. So basically there is one curvature here and another here, so these are the two here. We could also change the curvature type, G3 or G4. You can go on and give it a try, different way to blend them, and then just press OK. So this happened, and let's say I want to do it again over here, and it's done. So what is the basic applicability of it? Let's say we have a basic lofted surface. Always start with loft, so life is easier. Let's say I have something like this. and something like this. And I have to copy it somewhere around here, and let's say it goes here, loft them, and let's see what happens. So this is something, let's say it's a shell, and now I have to make a patch around the roof. So let's say I have a basic curve line somewhere around here, and let's rebuild it. I don't need to rebuild it, I just have to move them, patch it, let's see the preview, this happens. So let's say this is something, but I don't like the way the basic surface blends with it. Now I can easily use the blend command. I can use it in two ways. Let's say I just blend it from here. Let's say it would be easier to do it this way. Create a curved line, trim it just like so, and then delete the line, go into perspective, blend surface. So from here to here, it means blending, and we can see the blending is quite smooth, and we can change the curvature of blend. So I can do it like so, I can make a crease if I want to, and we can do it in many different ways. So yes, that's the way we can change the blending mode and use the blend command into making different shells. Let's just hide the curvatures, and also select similar is somewhere around this button, and this is our blended surface. This looks cool. Now there are other different interesting commands regarding surface edition. For example, I could just split surfaces, like say I have this line here and I want to split the upper part of the surface and the lower part of the surface according to this line, in reference to this line. So all I have to do is just type in split, then select the object that I need to split, and then select the reference. So there we are. There are the basic two difference, and then we can basically change the material or something like that, whatever we want. We can also delete one if we like. Let's say I want to make an entrance somewhere around here. And I'll just split it again. I'll just select this and reference these two, and yes, there we are. So there is the basic splitting edge that I need, splitting surface that could have the potential to become an entrance. So let's have some fun. Upon pressing F10, we would have some control. So after pressing F10, they come up. These are called control points. I could also turn on solid points on, that is also another command. And then I could just move this command, move these control points any way I like. So yes, that could be a solution to our entrance. We could get different curvatures around them. We could also sweep them. I'm not going into sweep again, we have discussed it upon previous class. I have something else in mind, so keep patience. Now let's talk about flow along surface. What does it do? Let's say I have a high rise. I'm going completely eyeballing without any sort of measurements whatsoever. so bear with me. No, that is not the way. Yes, this one, and let's make it into a high-rise shell of some sort. This would be ground, this would be somewhere in the middle, and this would be our top. An interesting form, and we are going to loft it. Select it sequentially and just loft. So let's say this is one type of surface that needs some sort of facade fenestration. So let's make that facade fenestration. In order to do it, let's learn a new command. I could do it in any way, but this would be more accurate than any. I would use the unroll surface command. Anyway, it doesn't work here, it's a doubly curved surface. I will tell you later how it's done. But let's make something else. Let's say I have a hexagonal grid now. Any type of grid. Let's say I have just this type of grid right now. Hexagonal would be nice, so let's go for hexagonal. Let's make offset out of it. Offset somewhere like this. Create an extrusion. Something like this. And now let's copy it to our heart's content. We could also array it, but arraying it would create some different types of problems, like we could not have this type of pattern. So let's just make it like so. So this is our basic hexagonal pattern, and I have something like this around here, and let's just copy it over and over and over again. Let's say this would wrap around this basic high rise. So just before doing anything else, let's trim it into a straight line so that they all are in one level, one straight level. So yes, this looks good. Cap them. Let's see if we are okay with it. Yes. Now the interesting command. Let's click upon them, select them. We have to have a plane beneath them. So let's create a basic straight plane. It has to be referenced so that every unit is in it. Not one unit is left behind. And let's keep them a little bit below. Now I would just select all of them. Before doing anything else, grouping them would be a nice thing to do. And now flow along surface, that is the command. It says to select a base surface, so the one that is beneath the units is the base, and then it tells us to select the target surface. So this one here would be the target surface, and we can see this happen. Now if we just delete it, we can see we have a beautiful hexagonal structure. Not so beautiful, but it does the work. If we would have the calculation and units properly, it would look really great. So this is one way to do complex facade fenestration, and we can see this is literally seamless, and we can basically hide all the lines like our previous thing. So yes, this is something that could be put into practical implementation. Rhino is not only for making shells of dynamic nature, it also helps us to create different types of fenestration as well with measurements. One thing that is needed to be kept in mind is that all the surface tools that are usually used are docked in here. Specific this fillet surface, if we click upon this small arrow, all the commands that we generally need would be in here. Also, in this basic surface command, basic surface tab, we would have all the surface edition as well. Now let's move on to the solid tools. Solid tools come in handy when we have different holes to make, or we have a large groups of solid to interact with one another. Now let's see what are the basic commonly used commands that are used in solid tools. So the basic solid commands are all docked in here as well as here. This is Boolean union, but if we press the arrow here and then drag it out, there are the basic solid commands. We can see there is Boolean union, Boolean difference, something like shell, there is one called hole, and things that we might need. But mostly we would be needing these Boolean commands. Let's see what they do. Let's say I have a box here, let's keep it shaded, and I have a sphere somewhere that is adjunct to this box here. Now let's say I want these edges to be filled. So if I just click upon here and then try to fillet edge, I cannot select this one. But if I basically click on the Boolean union and then try to do it again, what it does, this happens, and it's something beautiful. Nice. Let's see it into the rendered mode. You can see that it is basically seamless. So yes, this is quite interesting thing to do. And if we have a very complex geometry and have to work upon it, we can do it via using the Boolean union command. Now let's do something else. Let's say we have a plane somewhere around here, and I want this to be, or something more simpler, I want to remove this box from this plane. I would just select on Boolean difference, select the surface that I need to subtract from, and then select the one that I need the subtraction. So that's how the Boolean difference works. We could do it in many other ways. Let's say I have a box, I have a sphere, and I need subtraction. So I could do it like this. So this happens. Also, the basic Boolean command is also sometimes interesting, and it can give various results. Let's see. I have to have something else. Let's say I have a sphere somewhere. And now I have to Boolean them. Boolean to objects. And now I can click through the results. I can have this if I want, I can have this, I can have this. So all of them are different Boolean results, and this could be done via Boolean to objects. So that's how the Boolean works. Boolean also works with groups, and that's where these types of forms come in. Let's say I have something like this. I have one solid box this big and some basic cylinders. I'll just create one cylinder. The array would be the same as AutoCAD. So let's say I have some cylinders like this, and let's see if it's okay. Let's put it here and array. In x direction, let's say there are 30. Y direction, let's say there are 30 as well. Z direction 1, x spacing. I can basically do this. So let's say I have something like this, and I want to create a pattern, but let's make the array first. Let's create a group. And now if I want to subtract all of this along from the basic box that I just made, what I need to do is create boolean to object, boolean difference, select the box, space, select the group, space, and it may take a while, but it's done. So yes, it can save a lot of time, and it can be really life-saving in times of need. Now, one of the things that you almost face all the time is that you have a brilliant idea. You might manage to make a 3D, but when you have to make 2D drawings in your sheet, like plans or sections and annotations and so on, you face difficulty. So this is where surface to line drawing comes in. Also, it would help to annotate model drawings as well. So let's get into it and see how we can convert different surfaces into different types of drawings and then take them into different medias as well as physical media. So one of the way I could do plans and sections of an object is use the make 2D command. So this works this way. We have to go to a particular elevation or planar view and then select the object we want to make 2D of. For our understanding, let's make it shade, and we just have to type in make 2D. It asks us what to do. Let's see, we would use the front view, okay, projection of the view, okay, and from if we want to show different lines, we could use this. Say we want to show the hidden lines in our graphics, which we usually don't, but sometimes we have to, so it may come in handy, and so on, and just press OK. It takes a little while to generate the drawing, and we can see the drawing is generated. We would have to go to the top view. You can see here is a clean line drawing. So if we want to see different lines in different layers, all we have to do is go into the layers, and we can see there is a make 2D layer and there are sub layers into it. So we can basically hide the hidden layers for a better understanding. We can see this is the basic elevation, but if we want a more technical drawing, we can use this as well. So this is what the basic make 2D command does. Similarly, we can make sections as well. In order to do sections, we just have to go to top view, draw a section line, trim the side that we don't want, wait for it. It may take a while time to time. It may take several trimming scenarios to create a perfect trim, and then ungroup it as we have done it in group previously from our flow along surface. Sorry, ungroup again, and just delete the ones that we don't need. Go into front, and then all we have to do is just select it and make 2D. We don't need the hidden lines right now, so just like that we have a perfect section. Here is our section. We can now hatch it. Hatching is basically like AutoCAD. So let's create a boundary, yes, and then select, and then from our perception just hatch out the one lines that we need for section cuts. You can see it easily which are those. so no big deal. It requires just a little patience, but at the same time it requires a lot less time than compared to AutoCAD, so that's an advantage. We just have to keep doing it. Like that we can create all the hatches to our understanding, and then we can export all the drawings into AutoCAD. Let's just do it for fun. Let's just create the plans and elevations, export them into AutoCAD. So let's export selected, and then let's say I want it here somewhere. Let's keep things organized. So I think it's somewhere here where I'm keeping all the lectures. So it's fall 2020, ARC315 video lectures, lecture 5. So plans and elevation and section. Sorry, I think I have exported the wrong file type. I should have exported it into DWG, but while exporting you can see I have an array of options. I can export it into STL for 3D printing. I can export it into OBJ for any other type of 3D application. I can export it into SKP for SketchUp, and as well as Rhino. But for now, let's go for DWG for AutoCAD. Here is the AutoCAD DWG. So it should be named elevation and section, and save it. Let's make it default, and I think we could go here and open the DWG. Wait for it a little. It's taking more than usual. Continue opening the DWG file, and here we are. Here there are all the layers. I can still hide the hidden layers. I can see the hatch. I can select the hatch and change its type. I can do basically anything I like. I can change the hatch scale as well. From 1 to say 0.1, something like that. So basically anything I like, I can do it. One of the other things from 3D to curve would be the ISO curve. So let me explain what it is. Say I have a sphere somewhere here, and now I want a line that goes along the sphere and intersects with it perfectly. So in order to do that, I could go here, and here is the extract ISO curve. I would have to select the object, and we can see it does it. So I can change the direction as well. Let's go into perspective for a better understanding. You can see the ISO curve is currently in direction U, and it goes from up to down. But if I wanted it to go horizontally, I could just change the direction, and you can see it does that. So yes, I could do that, and I could also go for both. So this could have been interesting. And now if I delete this sphere and try to make a structure something like this, we can do this and just create pipe. You can see it's a very nice, something like a bamboo structure also. So yes, we could do that easily. We could basically draw a sketch out any kind of 3D form and then manipulate it into becoming a structure, vice versa. Another interesting thing would be the unroll surface for making different types of models. Let's say we have a pyramid, but just for fun. And now let's type in unroll surface. It's that easy. Let's say we want to make a paper model out of it with making half cuts and so on, and then just after typing out unroll surface, we would have to say not to explode in order to keep the half cuts. And then just for our understanding, let's say we want to keep the labels on, and you can see this is the half cut diagram of the model. We can just now export it or make 2D out of it. Not perspective, it would be from top. And now we can, this is not right, we can basically export it, this one, into AutoCAD and make a basic line drawing and then print it out, or print it from here as well. I could just Command or Control P here and then print it into any paper I like. It should be printed from top view for perfect projection, and then we can basically give half cuts into these and this, and we could make a pyramidical model just like this one. It would be perfect. And if we want, we could also make flaps if we like, just manually create some flaps here for gluing better. So that's one way of doing it. Another way would be smashing. So let's say I have a curved surface now. Let's say I have something like this. And I would just loft them. And let's type in smash. Here is the basic half cut model of this surface. Now if I had this member and this member here, I could do it with this command. It's right here. And now if I made a pipe out of this and this by printing them, I would just easily glue them with these pipes and then create the paper model out of it. So that's one way of doing it. So that's that. We could make easily paper models out of our 3D models. That's a very handy tool to have. Now let's finish our lecture with the assignment and another interesting command named contour. We would be making an waffle structure, and I am showing this image just for a reference. This is exactly not what we are going to do, but this is the basic impression that we might be using for assignment. And I would be expecting from all of you to get a complex geometry with something like this. So let's start. For this, at first we would have to definitely select the perimeter of the structure, which would be something like this. Nothing is full and final, so don't worry about it. We would edit everything, almost everything, so no need to worry at all. Just eyeball it. Something like amoeba at first, then we would change it into something more interesting. So let's say this is the first thing we need to do, and then let's make the columns that we would be needing. So let's just copy them to different places. We could give one here, so let's make space for it. Yeah, this should be done. let's say these are the columns. So this is the basic plan of it. Let's just make a planar surface from it. I'm going to use all the commands that we have discussed time to time. Let's trim it from top. Go to wireframe. This is going to be a little difficult, but no. Let's just select all the outer circles, press tier, go into shaded. This is a workflow that you might need to follow time and time, so don't worry about it, you will get there by practice. And now let's make some little extrusion with these ones. Little, not much, and then let's just blend it, blend surface. So this one with this one. Let's change the curvature a little. Okay. 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 And okay. So this is the base. Now let's copy this one and just type in untrim. Or we could just patch it, that would have been better. Or not. Let's not do it. Let's rebuild this one. Let's say 10 and 10 is nice. Press this one or solid points on. Or I really don't want to press F10 because my recording would be stopped if I press F10. So anyway, let's press it. So after pressing F10, this happens. And now let's just eyeball them and deform it like so. Not bad. Blend this one with this one. Sorry, it should be blend surface. This with this. So we now have our basic geometry right here. Let's hide the curves, all of them. Let's select everything and press J, enter for join. We could also do boolean. Joining in this scenario seems legit. And now let's go to top and select the contour. We could just type in contour base point and perpendicular. So there are way lot of contour. I should have changed the distance. I'd expect you to do a basic unit setup first. I'm just eyeballing it right now. For you, you should do it in meter. So let's do it one more time. Let's select contour. We can change the distance somewhere around here. Let's see, join curves. Range, assembler, join curves, object by plane, contour base point, range. It should be so there are basically no way to understand. Yes, now I can basically change the distance. After I set the direction perpendicular to the contour, I can set the distance. Let's say it's not 1, it's 5. Yes, this is much better. Now let's take all of them. We can see the contours are in 3D and they're really nice. I can do whatever I want with them. But first, let's say I have a new layer somewhere. It's out of the default. Sorry, I should have done this. And change the contour layer. And now let's make extrusion out of them. I can change the direction. I'm eyeballing it again, and they should be solid. So let's say the contour direction is somewhere here. We already have one part of our waffle structure. Now let's do it again. Let's go to the top. Keep in mind, for contour, the direction has to be normal of the direction. So for this I went this way. So for the other way around I would have to go this way. So let's type in contour again. This time the direction would be automatically 5. So distance would automatically be 5. So I don't need to change them much. And do the same thing again. Change the layer, change the extrusion, and I think they are nice to go, ready to go. I could type in the extrusion as well, but I prefer it this way. I'm leveling everything out. So yes, that's an interesting thing to have. So that is our assignment. Not exactly this, we can go with any type of geometry you want. The more complex, the more mark you will get, and that is fun to do. So have fun. So goodbye for now. We'll see you in the next session.